Welcome everyone for our second week of the online tutorial session, and today we'll be discussing about antiderivatives. Okay, first, what is the definition of antiderivative? I'll write down the definition first and explain it with some examples. Okay, so a function capital F is called an antiderivative of f of another function if the capital F, if we differentiate the capital F, you should get the simple f. I'll explain it with an example. So if we choose, let's say, simple f as x cube, then what should be our capital F so that when you differentiate this function, you should get this as the answer, right? Now, we know that we can just observe that this is a very simple polynomial type. Right, so we know that when you differentiate x to the power n, upon differentiation you will get n times xn minus 1. So just by looking at these numbers, we can kind of evaluate or extract out the required fx. There are no any particular techniques, but we are doing this just by the knowledge of, by making use of the knowledge in differentiation, right? So in order to get 3 as the power, we should get n minus 1 in this general case. That means if we have x to the power 4 as the power of our capital F, then when you differentiate capital F, you will get 4 times x to the power 3. So we are done with our x to the power 3 term. But the problem is we should write down a certain function capital F so that when you differentiate that certain function, you should get the given the given simple fx, right? But here the given simple fx is x to the power 3, and if we write down capital F as x to the power 4, and when you differentiate the capital fx, what you will get is 4 times x to the power 3, which is not the original function. This is not equal to the simple fx, right? But if we write instead of writing it like this, if we write our capital fx as 1 over 4 times x to the power 4, right? And then if we differentiate the capital fx, what you will get is 1 over 4 times 4x3, and that will give you x to the power 3, which is fx, right? Okay, so let's go through it one more time. We are given with a certain function, which is x to the power 3, and then with the knowledge of derivatives, we found out that if you have this one, if you have another function capital fx, so that it is defined like this, and when you differentiate this capital fx, you will get simple fx as the answer. In this case, we say capital fx is the antiderivative of simple fx. But this is not the only case of such a function. That means there can be couple of more other functions which has the same property. Now, for example, if instead of writing capital Fx like this, how about this? If we write capital G as 1 over 4 x to the power 4 plus 10. What will happen when we differentiate gx, capital Gx? When you differentiate capital Gx, you will still get 4 times 1 over 4 x3, and when you differentiate 10, you will get 0. So this is again simple fx. So that means even when you differentiate gx, you will get fx, and also when you differentiate fx written like this, again you will get the same answer. That means this simple f function has two antiderivatives. In fact, whatever the number you use here, upon differentiation, that constant will be vanished and it will give you this term as the answer. In other words, all the functions written in this format for any arbitrary constant c, when you differentiate, you should have 4 and 1 over 4 here. When you differentiate this function, you will get x cube in here and plus 0, which is simple fx. And that means there are infinite number of antiderivatives for this given function. Now, if we take another example from the first tutorial, I'll take the part E of question number 1. For part E, you have fx is equal to 4ex. Right. So what should be the function so that when you differentiate this function, you should get this as the answer. So we have to find this capital F unknown function, right? And we know that when you differentiate ex, you will get the same function as the answer, right? And here you have 4. So now here, in order to calculate the antiderivative, we are making use of the differentiation knowledge that we have. So first of all, we should be very much familiar with the differentiation techniques to come up with the antiderivative, right? We are not doing any sort of a rule or anything like that. We are just thinking backwards from the differentiation, right? So in order to get this one, if you write the function like this, function also as the given original term, and when you differentiate this one, you will again get 4ex. But this is not the only possible solution. Even though you write any other constant term as an addition, you still can get this one as the antiderivative of this simple function, right? Because this is a arbitrary constant, and constants will vanish when you differentiate the terms. Okay, so you have to do all the remaining questions of this worksheet in the similar way. The main thing you have to keep in mind is you should observe the given simple function and think backwards from differentiation, and you should figure out what is the suitable function capital F so that when you differentiate this capital F, you should get the original, the initial function as the answer. And don't forget to add a arbitrary constant, because when you differentiate a constant, that will vanish and it will yield out the same answer.